So, hello everyone, welcome to day 47 of Learning Data Science. And basically, today is day 7th of Learning EDA. So, in this 47 days, in these 46 days, what we have learned, we have covered Python. And in again, Python, we have covered the two projects, which is Employee Management System and Library Management System. And then we have moved into EDA. In EDA, in these 6 days, what we have learned? We have learned about all the four business moment decisions. And what are those fourth moment business decision? I want you to just write it on the comment section, okay? Because I've already explained it, okay? So we have covered with all this. And yesterday we have started with the graphs as well. I have discussed histogram. I have discussed about box plot, which is obviously univariate plots. And again, what is univariate plots? I want you guys to just write it on the comment section. What is univariate plots? Okay. What do you mean by univariate plots? I've already explained yesterday, right? So all these things you have to write it on the comment section. And today, what we'll be going to do, we will be discussing more about the graphs, and it might take me a couple of days. For example, for today and tomorrow, and day after tomorrow, we will start with data pre-processing. And after data pre-processing it's completed, then we will starting with the SQL. Okay, then Power BI, then machine learning. Okay, so it's a long way to go. So yeah, now we'll start with the things. Just give me a second. Okay. So here you can see yesterday we have discussed all these things. What is Q1, Q2, what is these all things we have discussed it yesterday itself. And today what we are going to do, first, let me tell about what do you mean by normal distribution. Okay. So you might have heard about, I have already explained what is meant by normal distribution. So I will just online here. Okay. Oh, come on, yeah, I'm not able to draw. Basically, this don't consider this. Please pardon. Don't consider this. Uh, b- And if we divide this graph into two equal halves, okay? If we divide this graph into two equal halves, so we can see here this part is equal to this part. Okay, my first part is equal to second part. Okay, or I will write like this. This is my first, this is my second. And in normal distribution, my first is equal to second. Okay, and basically we are dividing these stubs into six sigma stubs. Okay, and what is again six sigma we will learn today. So say this is -6, this is -5, this is -4, this is -3, this is -2, this is -1, and this is 0. Okay, sigma, 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 sigma. Okay, again this is 1, this is 2, this is 3, this is 4, this is 5. Oh, sorry, this is 6. Oh, yeah, now it's looking good. And if we will go from here to here, from -1 to +1, then it's How much? 68. 68 point. Sixty-eight point 26%. If we will go from -2 to -2, then it's 95.46%. Similarly, if we will go from -3 to +3, it will be 99.73%. Similarly, if we will go from then it will be 99.99%. And similarly, if we will go from -6, so it will be around 100%. So you can see here, what is this percentage? What is this percentage? Here, basically the data, okay. Here, basically the data, here you can see the data total of how much data it covered. It covered 28.6% of data. From here till here, it covered 95.46. Similarly, you can see from here till here, 100% of data is being covered. Okay. So what is basically this sigma? What I am talking about? Okay. So basically these are the Z scores. Okay. And these are sigma. These are Z scores. These are these are Z scores. Okay. You can watch this video by doing into 2x times. Okay. It will be quite easy for you. I'm just going slow so that it will make you guys understand. And what is the Z score? It is, we do normalization. Basically, sorry, not normalization. We are doing standardization. Okay. And again, what is standardization? These all things we will learn in data pre-processing steps. But as if for now, I want you guys to just be aware of it. What do you mean by standardization? And why do we use standardization? This is called standardization. And again, what do you mean by standardization? To convert categorical data to standard data. And basically, what is standard data? we use encoding. We will discuss these things, what is encoding, what is decoding. We will discuss all these things. Okay, standard data is basically scale free data. Okay, what is standard data? Standard data is scale free data. Okay, so standard data is a scale free data for that. And why we are using this z scores means like, and what's the formula pertaining to it? Okay, so basically the formula is z is equal to x minus mu divided by standard deviation. Okay, where where mu is 0 and and my standard deviation is 1. Okay, so basically here, and if we will take a sample data, for example, sample data is 1, 2, 3, 4, 5. Okay, this is standard data. And what is the mean for it? The mean for it is 15, sorry, 3. 1 plus 2, 3, 3 plus 3, 6, plus 4, 10, 10 plus 5, 15, 15 divided by 5, it's 3. So when we will calculate this value, okay, for the very first thing, what you will get? What you will get for the very first thing, my mu value will be 3. Okay. And what will be my standard deviation? What is the formula for that? It is summation of x minus mu whole square. You have to take this under root divided by n. So when you will calculate this value, so standard deviation will come around 1.41. And similarly, for my each data points, for my minus 1, for example, for this particular thing, for this particular value, what will be my z value? What will be my z value? It will be 1 minus 3 divided by 1.41. Again, where it come? This value, this came from here. X minus mu. My x was 1, my mu minus 3, my mu 3, and standard deviation 1.41. Okay. So similarly, it will have some value as minus 1.42. So like this, you will get some values. Okay. If we will calculate for 2 minus 3 divided by 1.41. So you will get around minus 0.70. Okay. So we will plot this, if we will plot similarly, it up to you. It's for you to calculate all the values for this and then write it on the chat what will be the values. And if you will plot this, you can see my minus value will be minus 1.42 till minus 1.42. Okay, and my graph will look like this: a bell shaped curve. A bell shaped curve will be there. Okay, a bell shaped curve will be there, and in between there are values. You can say it's 0, 0.70, and here also it's 0.70, and this is in minus. Okay, and what this is called? This is called standard normal distribution. What's this called? This is called a standard normal distribution. Okay, so why we are calculating this? We are calculating for this purpose. We are calculating this for this scale free data. Okay, we are calculating for this purpose. Okay, if I will minimize it so that you can take a screenshot of it, why we are calculating all these steps. Okay, so basically you have to understand that whenever we are taking the values from -5 till +5, then you can see most of my data will be covered. Okay, and accuracy again, means like it again, it's for identify when we are handling the outliers. Okay, so when we have to take the data, uh, it might happen that we might skip some of the data, right? So we have to make sure that our graph will be so well designed that none of our data is skipped. Okay, while we are treating the outliers. Okay, so for that particular reason we are using here, which is standardization, and we are converting our data into a our categorical data into a scale free data, and scale free data which will look like a simple bell shaped curve will be there, and we are standardizing the values, and we are again standardizing the values with the Six Sigma rule. Okay, we are standardizing the value with Six Sigma rule. Okay, so these all things were there when we discussed about some normal distribution. Okay, so what we will do, we will come on to the scatter plot. Okay, we will discuss quickly about scatter plot, and what's the thing, scatter plot. Okay, let me increase the size here. Scatter plot. Okay, so again, what's the primary purpose of scatter plot? The primary purpose of scatter plot is to check the data it is linear or not. Okay, I want you guys to note these things because this is an interview question. Primary purpose, what is primary purpose? It is used to check the data is is linear, strong, and also direction. So what are the three things of a scatter plot to check? Primary purpose, whether my data is linear. Linear means it's a straight line. Strong, strong means how it is correlated. And direction, direction means the slope, whether it's negative or positive. Okay, direction, whether it is positive direction, whether it is negative direction. So three parts, three primary purpose is there to check the data is linear, strong, and direction. Uh, Direction is the most important. It is it is most important. Direction, it is the most important. Okay. And what's the secondary purpose? What's the let me use this box. What's the secondary purpose? Secondary purpose is clusters. Clusters. Okay. Clusters, outliers, you can tell. Okay. And what do we mean by strong? Okay. So here we will be learning about what do you mean by strong? What do you mean by strong? It is correlation coefficient. It is correlation coefficient. And if we are using here mod and correlation is defined by R, and if my correlation coefficient is greater than 0.85, let me add here 0. If it's greater than 0.85, then what we can call it? We can call that it is strongly correlated. It is strong. My relationship is strong. A strong relation. And if my R value is less than 0.4, then what is there? Then what will be there? It is weak. It is weak. And my R value, it's between, okay? Mm. Then what do we say? We can call it's a moderate. Then it's moderate. So basically this is correlation coefficient and this determines the strong. Okay. And basically what is scatter plot? It is a bivariate plot. It is a bivariate plot. It is a bivariate plot. And again, what do you mean by bivariate plots? What are bivariate plots? We take we take two columns, two columns, two columns or features. We take two columns or features. Okay. And how does it look like? How does this scatter plot will look like? Okay. This is my y axis. This will be my x axis. And for example, if I'm using color, if I will, this is my data points. This is my data points. These are all my data points. Okay. And if I will draw a line from here, then you have to see how many of the data points does it lie on my this particular line or not. Okay. Does it lie or not? And how can we find this relation is by this particular thing. And what is this line? This line, is basically the direction, is basically the direction, the slope. Okay, whether it is positive, whether it's negative. So basically in scatter plot, we check how our two features are correlated. For example, this is we are plotting, and this is one feature. Okay, and this is my second feature. This is my second feature. Okay, so how this feature is correlated, correlation coefficient. With the help of that, we will be able to find it. Okay, so I hope you have understood this. The scatter plot normalization. You can take the notes. Okay, you can take the notes. You can take the screenshot as well. Okay, I think you have taken the screenshot for the first. If not, just put a left arrow and rewatch and take the screenshot. I'm giving 1 minute time. Take the screenshot. So today we have discovered about Z scores, the standardization, bivariate plot, which is a scatter plot. What its primary purpose? Its primary purpose is check the data is linear or not. Linear means whether it's in a straight line or not, or it is clustered in a way. And second, is it strong or not? Strong, how we can check? By the correlation coefficient modulus R. Again, why we are taking modulus R? We are taking modulus R because the R value will might come negative. So we are taking modulus so that it will just help us to make the values positive, so that any positive number will be positive, any negative number will become positive. Okay, so for that reason we are taking mod of R to avoid negativity. Okay, and what is direction? Direction here again the slope, the line, how the line will go, that will be decided. And secondary purpose, it's clusters and finding the outliers. Okay, so these are the things, and tomorrow we will meet at the same time. I hope you guys are practicing it. If you are not practicing, then start practicing it. Okay, and till then, bye bye, take care, Jai Hind.